Good afternoon and good evening, everyone. Welcome to the February 20th version of the HamSCIence Zoom call. We've got a couple of things on the agenda today. One is I'd like to put on the screen briefly the agenda for the HamSCI workshop coming up in a couple of weeks. A few of the people who are here that worked on the agenda and helped create it are here with us, so they can maybe give us a little insight on what we've chosen and how we've ordered things. The second thing is Mackenzie was hard at work on a poster describing the Meteor Scatter QSO Party that we were talking about last week and whatnot. And she's made a lot of progress on that. And I think it might be helpful if we put that on the screen in a little bit and gave her some suggestions if people see some are worthwhile. So is there anything else that anybody wants to bring up or throw on the agenda for today? Okay. Good. Well, let's get, if you think of something, let me know. Otherwise, I'm going to share my screen and jump into the agenda for the HamSCI workshop. Not it. Not it. Ta-da, there we go. Get Zoom out of the way. Okay, as I think everybody knows, we'll be starting on Friday, March 14th. We've got our usual couple of speakers from NJIT, the president of the university, and the professor and chairman of the physics department to kick things off a little bit. Our first session will be on the personal space weather station as we have for the past couple of years. Nathaniel, is there anything you want to say or comments you want to say about some of the speakers we got coming up?
Sure, Gary. So we will open up with an overview of what the DAISY 2 project is exactly, which it basically is a continuation of the first DAISY project, but now we're going to do more deployment. We have a much better developed set of instrumentation. So I'll be explaining that. I'll be explaining what the different organizations and institutions participating are, who they are, what their roles are. And then I will be passing the torch off to Gary, who will talk more about expanding the personal space weather station network. After that, we're going to have a couple talks, one from Kung Nugent talking about the data gathering and that he's been doing for the GRAPE 2s. He's been writing software to convert the GRAPE 2 data from the CSV format to the digital RF format. And he is responsible for getting that data that is currently on the systems that are out there, bringing that back to the University of Alabama, and his software is going to convert it from what's the raw data on that system into the data that can actually be accessible and stored on our server. Then we're going to hear from Michael Howen and the DAISY 2 antenna project. They're going to talk about different antennas that we have considered for the HF portion of the DAISY 2 project. And so actually, Gary, maybe you can talk to Michael and add in the words HF or MF and HF to that antenna project, because it's specifically focused on that. Because after that, we'll hear from Jonathan Rizzo, who's working on the VLF portion of the personal space weather station project. Then we have Jesper Yarlov, who's going to be talking about a magnetometer project that is a citizen science magnetometer project, but it's not the HamSCI citizen science magnetometer. It's one from another citizen science project. So he'll be talking about that. And then finally, we're going to hear from Christina Collins, who's going to be the chief operations scientist for the DAISY 2 project. She will be giving a talk about not only about the DAISY 2, but about some of her visualization work. And we go off to the coffee break.
All the all-important coffee breaks.
Yes.
So session 2 will be some of our solar eclipse observations and findings from October of 2013 and April of 2014. Kuldeep, who's here with us this week and pretty much every week, will be kicking that off, talking about some of the data and some of the modeling that he's been able to do using the roughly 52 million records that were generated on those eclipse days. I think it's quite something to hear about. We'll have Rachel Bodecker from Case Western Reserve. Mary Lou, of course, will be there talking about some of the projects that was kicked off, I think, on this call, probably around 6 to 8 months ago. And some of the folks on this call who've been participating from the citizen science perspective to help her analyze some of the data.
They've been wonderful.
Yeah, it's definitely worth crowing about. You talked about them at the AGU meeting too, if I remember right.
Not too much.
Okay.
That was mainly about Tonga.
Ah, okay, that's right. That's right. I'm getting all these conferences confused in my head. And then we'll have one speaker, one of Nathaniel's students from the University of Scranton, talking about the experiment that he worked on with, of course, it was led by Steve Serwin. And then Nick Hall Patch, who's been very dogged about initiating, following through, and collecting data for the medium wave portion of the spectrum. So Nick will be joining us from British Columbia, which is a good thing. And then I think that the following sessions are getting into a little bit more into the science and some of that sort of stuff. Jamal, who's on the call again with us today and most weeks, will be speaking with speakers from NJIT. Jason Durr will be on from, I guess he's in New Mexico now. He'll be virtual. Glenn, who's with us today and most weeks as well, will be doing an oral presentation on sporadic F. So that's to be looked forward to. And then Bob Gerzoff as well, with some of his interesting mathematical analysis on things. The session 4, Nathaniel, is mostly, well, not entirely, but mostly students, or no, I guess that's not true. We've got a little bit of a mix in session 4. Chris Deacon will be back with us this year. He's been on this call and he spoke last year, if I remember. And then the Friday night banquet, our keynote speakers, it can be a very interesting one. Bob Inderbitson, the Director of Marketing Innovation from the ARRL. So he's been a very good supporter of HamSCI. He's been at the workshop the last couple of years, and the league has definitely helped us as a partner in promoting quite a few different events, the eclipses and of course the upcoming World Amateur Radio Day thing.
Do you have a call sign?
Oh, for Bob. Okay, good. Yes, I don't know that, and I will add that. Good point. Thanks.
November,
He is
Quebec,
NQ1R. NQ1R.
Okay, I got that to add. Thank you.
Mhm.
Yeah, I guess that's a good point too. If anybody sees, thanks for speaking up. Anybody sees something that needs to change or be added, obviously let's speak up. Some more interesting talks and some things on the education side a little bit. Ron will be here there speaking about Kettering, amateur radio and E&M curriculum. Electricity and magnetism, if you're not an electrical engineer, that's one of those killer courses. It's usually later in your bachelor's, typically a junior year thing. But if you haven't been weeded out by then, E&M will usually do that. At least that's how I remember it myself. Nathaniel, Gareth, you guys want to talk about the invited tutorials a little bit, because you know these people far better than I do.
Sure, I'll start off with Lynn Harvey. So Lynn Harvey is a research scientist at the Laboratory for Atmospheric and Space Physics at the University of Colorado Boulder, so that's LASP. And she is an expert in the polar vortex, especially the middle to lower atmosphere portion of it. And I'm working very closely with her on a number of projects right now related to traveling atmospheric disturbances. And she is really the lead investigator on these some of these TID gravity wave grants that I'm a part of. So I'm very excited that she's going to be joining us. She's also the current chair of the CDAR Science Steering Committee. The CDAR is the Coupling of Energetics and Dynamics of Atmospheric Regions program at the National Science Foundation. And that's very closely related to the program that's funding our DAISY 2 grant. Then we're going to hear from Steve Serwin. He's also going to give us an invited tutorial. And I really wanted to make sure that we give him an invited tutorial because he is one of the people that just really has amazing insight on how to use amateur radio to do interesting science experiments. So he's been doing this for a number of years, and every time I talk to him, I always am like, wow, that's really clever. And so I'm super excited that he's going to be giving a presentation as well. He will likely be virtual this year, but I'm very glad that he's going to be with us. And Derek Kotzel, he is one of the people with the GNU radio community, and GNU radio is the open source signal processing package that handles that can handle quite a bit of the processing in some of the personal space weather station projects that we have, and other similar projects.
Great.
Maybe-
And you've known Gene for quite a long time too, as well. He should be.
Yeah, Gene
interesting.
is someone I've known, K2KJI. I've known him since I first got my ham radio license in New Jersey back in 1998. So when I was growing up and I first got my license when I was in high school, he was selling radios at a storefront in Caldwell, New Jersey. And that basically, at that point he was retired from his main job, but he had a whole career building and developing the transmitters and amplifiers that are used on the GPS satellites, the very first GPS satellites. And that's just one of the things that he's done. So he's going to give us an early history of global navigation satellite systems, which we more conventionally know as GPS. And many of you know Gene also, even if you are not from New Jersey, you may have seen him at Hamvention for many years. So he's quite well known in the ham radio community as well. And he's also an alumnus of NJIT. And Gareth, would you like to talk about Lou?
Yeah, the other tutorial we have is Lou Lanzarotti, Dr. Lou Lanzarotti. He is a distinguished research professor here at NJIT. He's been in the field for probably as long as Gene Nemiek there. Lou started out at Bell Labs and then eventually came over to NJIT, but has been studying space weather and the radiation belts and all that fun stuff for since the 60s, I think, since about that time. So yeah, he's written quite a few books about space weather, about space physics, about great debates in space physics. That's his latest one. So he's I'm really excited to have him talk about just a history of space weather research in general, to kind of give a all-encompassing view in 30 minutes or less about the history of space weather. So yeah, I'm really excited for that one too. They're all good.
Yeah, I think this is the first year we've had 5 invited tutorials. So you guys have gone above and beyond trying to find folks that and get them placed. And then folks at NJIT got some interesting things once all the talks are done. Some tours of their makerspace, their campus. I've never been to New Jersey, so I'm interested to do a little bit of walking around and get on my feet after sitting and listening for a couple of days. The Collegiate Amateur Radio program will be back again this year. We had a panel last year, had quite a long meeting, probably more than an hour, of a lot of folks, young people involved with collegiate amateur radio. And we're going to get some more details on that soon. And then, of course, a lot of posters and demos. Right now, we've got about, I think, 13 or 14, maybe 16 posters lined up. Gwen's going to do a couple. We've got folks from all over doing most in person and a few virtual. Few people will be sending them in, and which is great too. So I think the poster hall will be pretty filled up, and I've been promised that we're gonna have quite a few more yet. There'll be more coming in. So. And I've never expected one on Turkish Morse code, but I think this will be quite interesting to hear that what the school students have done with Arduinos and that sort of thing, trying to
I
joint
think
Morse
she-
code with the,
I think she's
Yes.
on here today.
okay.
Yes, I'm actually here. Thank you so much. And also my students and their parents are here also. I don't know if they are okay to say hello or not. We're actually really a beginner on ham radio studies. And the project is my students' project. I can just say this, and I see my students cameras are on also. Maybe they will say hello also.
Yeah, hi,
Fatih and Aleha and our parents.
yeah.
Yes.
Hi everyone, I'm Ahmet Hayrettin Yüzer. I am the father of that children. They are preparing this project. In Turkish, some words are very important because some similar words to the C or G, something like that. So if you use different letters, it change the meaning very differently. So it is important for us to say correct words. Otherwise, you can change the meaning very different. So we are trying to add some new codes to more codes to say correct word.
Excellent. Well, look very much forward to seeing the poster. I think people will find that very, very interesting, and especially involving all the students and whatnot. That's the way it should be.
Thank you so much for giving the opportunity to my students for being a part of this amazing thing, I can say. And I don't know, I think it will be excited for my other students also. We will share our experience with the whole school. And
We will be sure to take some pictures and hopefully some videos of your poster in the poster hall. So.
Oh yes, we can do, I think.
How old are the students that you deal with?
Actually, the idea is based on totally on my students. They are fifth grade students, like middle school, and they are talented
13
and
years.
gifted. Yes, 13. Yes, and they are talented and gifted students. I'm teaching talented and gifted students by a science and technology teacher in Karabük Science and Arts Center School. It's not a private school, it's a government school, and we usually study on project-based education. So I was searching on websites and I saw HamSCIence, and then I attached your email and I was following for months. And then we were studying in our amateur radio station. So my students said we can maybe make Morse code with Turkish alphabet also, and now we are here.
Well,
That's
fantastic. I know we do a lot of promotion. HamSCI has a fairly good web presence, and but we still think of ourselves most of as a North American and Northern Europe type organization. It is wonderful to see people from other parts of the world join in with us.
Yes, thank you. And I would like to thank to my parents also, because Mr. Ahmet Hayrettin Yüzer is also electric engineer in Karabük University. So he helped us on some kind of coding or the other things at home. Also, I was in the school, and it's nice. I think it was a nice cooperation with a student, parent, and the teacher for us.
Yes, actually, I am an electronic engineering. I am working at university as an associated professor position. I am working on microwave engineering. I have designed high frequency circuits, but I really appreciate the amateur radio's peoples because you have too many experience, maybe more than us. Sometimes I'm following the page over Facebook or another websites. Sometimes I'm realizing that they need some information, but they have too many experience more than us. So I'm following them. So sometimes I'm detailer trying to read that paper, something experience to learn something new also for us. Even if I'm a professor at university, but still I have to need something to learn. So I really appreciate your efforts.
Yes, HamSCI does, many of us, we're all very proud to be part of the organization because of how much information, and one of our core values is to teach people. We very much want our activities to be a two-way street. The amateur radio community helps, of course, generate data and do other things for research purposes. But especially over the next couple of years, I think you will see more and more things from HamSCI going back to the amateur radio community to help operators and that sort of thing. So it is good. The cooperation is very, very good. All right. Any questions on the agenda? One thing to say, I will put the links, there's a few missing links. I will fill those in after the meeting tonight. And those of you who are planning on attending virtually, we usually send out the virtual links. I think it's just a couple of days before. Is there anything else, either Nathaniel, Gareth, or Kuldeep, that you guys could think you want to bring up about the conference while we're here? Nope. Okay, good. Good. I guess we got it covered pretty well. All right. If we could, I'd like to shift gears a little bit. As we talk about different projects and things, one of the ideas was proposed by Mackenzie here. Was the Meteor Scatter QSO Party for later in 2025. And if those of you who were last week will know that we discussed some of the options, and there's been a lot of good input on the HamSCI Google group as well. People who have experience with Meteor Scatter have been sharing their experiences, which is quite helpful. So we asked Mackenzie to put together a poster for the HamSCI workshop. I think that does a couple of things, as Nathaniel said. It says, we need to think about what science questions we might want to answer, kind of start there, and then see how the QSO party kind of wraps around that. But I think putting your ideas and stuff on the paper, and then us looking them over will help clarify what the event should be all about. So Mackenzie, do you want to share your screen, or do you want me to bring it up from the web? What's your preference?
I can probably share my screen, so if people have suggestions, I can just kind of edit it right there. Let me see if I can do that really quickly. Okay. Can you see it?
There we go. Yep.
Okay. So how should we go about this? Do you just want to go over the questions really quickly?
Well, let's
Or have
zoom in
you
on the
actually already gone
abstract.
over it, Gary?
I'm sorry, again?
Have you been able to actually look over it? Or you, Ed, or Nathaniel?
I read it over once. I was down in a workshop most of the afternoon, so I looked at it for about
Okay.
10 minutes.
Okay.
Do you want to just, why don't you just zoom in on the abstract? We'll start there, and then we'll move down to the science question.
Okay, let me see.
There you go.
Can everyone see that okay? Okay. All right, so I started off by kind of just describing what the event actually was. And I kind of changed it around a bit because we decided on just strictly using MSK 144. So I fixed that first sentence right there, and we decided to use WSJTX for that. A little more down here describing what the goal is. The primary goal is to generate dense, geographically diverse data sets to analyze the feasibility of HF meteor scatter for future scientific research. And then this last little sentence kind of describes the meteor showers that we're going to focus on. The first one being in August and the second one being in December. So does anyone have any comments about that?
No
Nope,
news is
nothing.
good news.
Okay. And then I kind of just went over the introduction to Meteor Scatter, kind of just what it is, if anyone wants to read that. Explaining right here, while Meteor Scatter has been extensively studied on VHF, its potential on HF bands remains underexplored. So that's kind of the whole point of this QSO party. We want to kind of dive into HF Meteor Scatter. And then these are the questions that I had wrote or written, kind of still trying to figure out what we want to do specifically, but if anyone has any suggestions for more scientific questions for this event, I would greatly appreciate it because this is what I have so far. Sorry, my dog's in the background.
So yeah, let's take a
let's-
minute and look at these closely. These are important, right?
Okay, let me read it real quick. Okay, the first one says, what is the typical duration of HF meteor scatter reflections, and how does it vary with meteoroid size and velocity? Do we think that's a good question for the first one?
If I read your previous paragraph right, it looks like you have a 72 millisecond transmission that repeats every 15 seconds. Is that right?
Yes.
Is that going to be enough sampling to even answer that first question? I mean, the burn is typically longer than 72 milliseconds, but a lot of them won't last 15 seconds. As I recall.
Okay.
In other words, is the mode that you've picked suitable to answer that question?
Oh.
In other words, the transmission length is really short, 72 milliseconds. They only happen every 15 seconds. What if you had a 5-second burn? You could miss the whole thing.
Okay,
Well,
I see.
Is that a good description of MSK 144? That the transmission bursts are 72 milliseconds for sure, but they're repeated very, very frequently. So it's not 72 milliseconds and then you wait for 15. I think there's a series of bursts that are 72 milliseconds long, and they're repeated because obviously the meteor scatters are so fleeting.
So what's the 15 seconds?
That's just how long it takes to kind of cycle through, right? For the MSK. Unless I got that completely wrong.
Yeah, I
Gary,
think you're close. I think you're close.
Did I get that wrong?
I don't know anything about MSK 144.
I can
All right,
make a note
we'll
here.
take a quick look.
Just...
We'll look at that in a little bit. So make a note there to.
Okay. I'll make a note here. Okay. Anything else from the introduction that anyone had questions about?
Can I just make a comment, Mackenzie? This is Bruce.
Go ahead.
Yeah, just to clarify for everybody, the short bursts are repeated over and over again for a period of 15 seconds. So you're transmitting for 15 seconds in a long series of that series of bursts. Then you listen for 15 seconds. It's the same as the other modes in WSJTK, like FT8, where you transmit for 15 seconds or 7.5 or FT4, and then you listen, transmit, and then you listen. So that's why the 15 seconds is in there. Does that help?
And yes, it does a lot, because that will give you enough resolution to do what you want to do. Are these coordinated? Like, do you get synced up with top of minute so that some people know exactly when they're transmitting and when others are listening and that kind of stuff?
Yeah, WSJTX gives you a delta on the time, and it's down to tenths of a second. So within that 15-minute window, as long as your local computer is synchronized correctly, then you're going to be synchronized with everybody else for the start and stop of that 15-second interval.
Now, if you have that's like a 15-second integration time. Are you able to tell within that 15 seconds when the meteor scatter is successful and when it's not? Or is it just you're like, here's 15 seconds, you can tell that during this 15 seconds it was successful or not, and you don't have any knowledge of what's going on inside of those 15 seconds?
Yeah, WSJTK gives you a a visual of the spectrum during the scanning period,
Right?
what you'll see is you'll see fairly intense activity during the very short bursts. So what you're not doing TDI over 15 seconds. What you're doing is you're trying to capture a very short meteor trail over a period of a few seconds, if you will,
Mm-hmm.
during one of those 72 millisecond bursts. So you're repeating them over and over again, and you're trying to, in that 15 seconds, you're trying to catch one or more meteor bursts or ionization bursts, which could be anywhere from fractions of a second to several seconds.
So are you saying that if we have an image of that waterfall display that was taken during that 15 seconds, we should be able to answer that first question?
Yes.
Okay. But along with that, my understanding is it would not be typical practice that people operating WSJT would be keeping those spectrograms. They'd be keeping a log of who they talk to, but unless we give people specific instructions, we're not going to get that spectral information back from people.
Yeah, I think that's a really good point. What we should do is look a little bit more into what the spectrum looks like and how it can relate to timing. If you can
Yeah.
see it burst on the spectrum, you want to correlate that to where it happened in the 15 seconds. I think that's what you're talking about, Nathaniel. And
Right.
we can look into see if we can capture that.
So Mackenzie, this helps to answer a couple other comments I had about your poster. So one comment I have is that this poster's, I mean, first of all, I would tell you, you're doing absolutely amazing work. So like, this is really, really good. So any criticisms I give are purely to be constructive. So
Thank you. Yeah.
one thing I might suggest is that you try to include more figures in your poster to
Okay.
make it more visual. And of course, you don't want to put figures there just for the sake of, pretty pictures. Of course, it's always nice to have some pictures of, happy ham radio operators operating and, that sort of
Right.
thing.
Okay.
But I think here's a really good example of where a figure would be nice. If you were able to have a screenshot of an MFSK 144 meteor waterfall, which could show where you could show, look, here is the enhanced, here you can see the meteor scatter communications occurring, and you can actually see the time duration that it takes, and you can use that information to answer this first question. That screenshot would be a really nice thing to include in here. And then along with that, later in the poster, when you're coming up with the procedure for the experiment, we have to have some way that we get the participants to send us those spectrograms, and ideally we actually have them send us numerical files that we can then plot and then post-process afterwards. But the next best thing is if people are sending us image files. But so that might be trying to understand what the settings on WSJT are better and see if like WSJT can, as a routine measure, produce files with water spectrogram numbers, waterfall numbers.
Yeah, Mackenzie,
That
this
are
is you.
appropriate.
Yeah, Mackenzie,
You
this is
could-
get WX2R.
Yeah.
Joe Deskovich, K1YOW, sent me a screenshot of a meteor scatter contact he had about 48 hours ago. I can move that to you if you're curious.
Oh,
Okay?
yes, please.
Might help.
Yes.
Okay.
Yeah,
Yes,
that's
thank
exactly
you.
the sort of thing we could use.
Yeah.
If you had the waterfall, you could get the length of the return as long as it was
Yeah.
kind of centered in the middle of your 15-second thing.
Yeah.
Didn't run off the ends.
Is anybody going to be doing any optical experiments with this, LiDAR or
Recording in
anything?
progress.
Oops.
That's a
I
good
think at this
question,
point,
Eric.
Eric, we're talking more about 6 and 10 meters, I think.
Yeah, I
All
just
right.
LiDAR gives you a lot quicker response on when a meteor event's actually happening. So I just wondering if anybody was involved with that at all.
It's a really good question, Eric. You know, certainly as we define the times that, you know, the days that this is going to happen, you know, we can try to talk to other members of the CDAR community and see if there are ways that we can do a coordinated campaign. So we not only have the ham radio measurements, but we also, maybe we get optical measurements. Maybe we can get the ISRs to run at the same time and look for things. And that would only enhance our data set.
And then
Yeah,
the astronomers have campaigns for this sort of thing too.
okay, yeah. The last at High Pass Observatory, boy, this is 30 years ago. We had the LiDAR set up there for the Leonid shower, and it was pretty amazing what we were able to see with that.
Mayor, that's a really good point. Would now the meteors that, is there a way, Mary Lou, that we could get the amateur astronomy community to take visual images that could be correlated with the radio communications?
Yeah, they usually have campaigns like that, but the American Meteor Critical Society or something like that does that sort of communications. You need to talk to them.
Yeah, that's a really good idea. And this is nice too, because this is a sort of thing like, you know, we're getting these different ideas. It could turn into a multi-year project where we do like a campaign every, you know, each year or something like that. That's kind of cool.
And I think it's interesting that some of these meteor showers come every year and they're the same time and the same amount, but there are other ones which are cyclical. Every 30 years, there's a huge burst of stuff, that sort of thing. And those are particularly interesting showers. Like the Leonids in November.
So this question is definitely something we can look at more, right? Okay. Let me just make a little note. Okay. Any other comments about the first question? Okay, nothing heard. Okay, the second one says, how large is the ionospheric region affected by meteor scatter on HF bands?
From what I've heard of MSK 144, you don't have enough information to do that. But if you had specially equipped stations that were synced up with, you know, GPS DO discipline times of transmission and reception, and you know you do know the distance between the stations because it gets your call sign transmitted, so you do know exactly who you got it from, then you could calculate the height of the burn. You could, with time of flight, you could calculate how long the path was.
Okay.
It's a better way of saying it.
Recording in progress.
Do you think this question is worth keeping up here? Okay.
How would you answer that?
Well, that's what I'm trying to figure out. I just kind of posed a question to see what people thought. Because I'm no means an expert at any of this. I came up with the idea because I'm interested in meteor scatter, and some people in my club were talking about it quite a while ago. And I've presented this to Gary and Nathaniel, so we're kind of just coming up with questions along the way to see what works and what doesn't work.
I mean, the way I would guess you'd go about answering it is if you had enough people trying to make meteor scatter QSOs blanketing a geographic region, if you could plot all those QSOs on the map and kind of see the boundary of where the QSOs appear and where they drop off, that's how I would try to map it.
Yeah, it could be a worthy goal to try to get that kind of coverage. get it dense like that.
It's certainly, you know, helps to motivate, you know, why do we try to get lots of people all over the country or the continent or wherever doing this? You know, you're trying to see where you're able to successfully make contact and where you're not. If you can find that boundary of where it drops off, that might help answer the question.
Could you use PSK reporter for that to kind of help visualize? Or would that not work?
I don't know. I mean, certainly for when I'm trying to answer HF questions, I try to use PSK reporter. So, you know, I don't know. Yeah, it's possible, I guess. I don't know enough about how this mode works to really be able to answer whether PSK reporter is helpful here or not. I do know that WSJT, I believe, has a mode where it will report to PSK reporter. So presumably everyone who's running WSJT and participating in this experiment will also have the ability to report everything they hear to PSK reporter, whether they talk to those people or not. So you could even encourage people in this, you know, just like we said, have the Gladstone Signal Spotting Challenge. We can encourage people that, hey, look, even if you're not actively operating, leave your radios and PSK reporter on and WSJTX on and have it reporting to PSK reporter. And then that's a way of us, you know, getting data. And it's potentially a lot easier to have someone leave their system on for 3 or 4 days and not have to actively be sitting there operating, and gets us more data.
So maybe that's a little homework we can do, is to take a look at the PSK database from back in November, look for QSOs and MSK 144 and just kind of see what shows up based on past history.
Yeah, definitely something to look at. Does anyone else have any comments about number 2? Nothing heard. Okay. And then the third one is, what is the relationship between the size of the meteor and the strength of the HF meteor scatter reflections?
There might be a correlation to time, assuming bigger meteors take longer to burn up than smaller ones. So the longer you get a signal, you might infer that path enters into it, direction, but you might infer that the meteor was bigger because it took longer to burn up and left a longer ionization trail, or it was ionizing longer. I don't know.
Is there a data set out there that indicates how large the meteors are for a given shower? I mean, that you would think you would want to correlate that against some of the reception data that Steve's talking about.
Yeah, how do you know how big the meteor was? Other than how long it took to burn up, maybe.
Yeah, and how bright it is as it's burning up. And it's another category. Does it finally go kapoosh and give you a fireball at the end, a bolide?
Or split into pieces. I've seen that. That's awesome. Yeah.
It strikes me as interesting as well how being able to look at, say, the American side, first of all, initially for this, at the same time as considering what's happening in Europe with the shower at a slightly different point in terms of elevation above the horizon. So the angle of the meteor input is probably going to be different, isn't it? Have I got that right? That depending on where we are in the elevation above the horizon, you would expect the trails to be shorter, the steeper it is, and so on. So at the same time, these data sets would show, because you're only going to be able to do it one set in Europe and one or two sets in America, aren't you? You won't get the bit in the middle across the Atlantic, because there's nobody in there to do a single hot path. So that would be quite interesting to see if you've got a bimodal sort of duration.
But also, airline pilots are very interested in these things, and they often take pictures. Can we get the Airline Pilots Association involved?
Mm.
Oh,
One of my friends is a pilot across the Atlantic, and he's always sending pictures of various stuff.
Excellent.
It's
Yeah.
kind of boring, evidently, so they do other stuff.
That sounds awesome.
Some
If
of them
it-
put their HF radios on the air. I've talked to a bunch of them.
Yeah.
I guess I'd say number 3, that's kind of maybe a little questionable because we don't have unless maybe other people know, I'm not sure how we come up with the meteor size that or a data set of meteor size.
I think the astronomers will have something on in their data resources, from what I've heard. They've looked at them for long enough, and I sense when I was looking up something the other week that some of these meteor showers are quite well defined, and others, as you said, you get this every 30 years, you get a peak in one of the showers that isn't repeated the following year. So it sounds to me as if they've probably built up quite a good archive of response, and they'll have a distribution somewhere. I don't know who you'd ask, but somebody would know.
Also, these meteor showers, each is a remnant of a particular comet.
Mm-hmm.
And basically, we go through the comet's leftover tail every
Yeah.
year at the same spot. And sometimes there's a good deal of information about these particular comets, what the parent body looks like. And they may have different chemical elements more prominent in one than the other. So there might be something interesting there as well.
Yeah.
If I can share my screen, I'll show you what the software looks like when it's running.
yeah, I can stop sharing for a moment. Let me see. There we go.
I hit share, but I'm not sure what's happening. There.
There it is.
Can you see it?
Yes.
Yep.
Now I'm on 6 meters. This is my remote access into my shack. I'm in my office in a nice warm. The shack's at 20 degrees right now. But this is 6 meters, and you notice some signature on there. And I've got my digital noise reduction on, and typically this is what you'll see on the top. Not much of anything going on other than noise on the band. And then if a signature shows up, you'll start to see something like that, if you can see it on the top. And it'll get really, I just turned my noise reduction all the way off, and you can see all this noise. So in 15 seconds, if you're lucky, you'll see 2 or 3 of those bursts. And then the time of those will be correlated to whatever CQ messages you're seeing on FT8 that are showing up over here under the transmit, if you can see what my mouse is doing. So hopefully that helps you see what's going on.
That looks great, Bruce. Does WSJT have a way of saving that spectral data to disk?
Well, what it's doing is it's creating an ADIF file. So, and I think Mackenzie covered some of that in her planning already. She mentions the.
Yeah, but an ADIF file is just an amateur radio data interchange format log file of who you've talked to. It doesn't actually contain all of the information you need to recreate that spectrum that's on the top there.
It won't recreate the spectrum. What it'll do is it will give you the time that the signal was received down to the second, or down to the fraction of a second.
But I think we really want that spectral information.
Yeah, there is a tab. There's a tab at the top that says save. The third one in from the left. one of the options seems to be save decoded. Whether that means what we're looking for here, I'm not sure.
No, I think what you want is a way to save the WAV file itself. It is a sound card, of course, sound card
Yeah.
interface.
Yeah.
I don't know if you can tap it off. If the program doesn't, there's probably a way to tap it off in
Yeah, we
software.
can look into that. If it can be done, I'm sure WSJTX is probably already doing it.
Yeah,
Yeah,
it'd be
It's worth looking into.
ideally, if it would be ideal if the WSJTX software were able to save the WAV files directly, and if it were able to save either in the file name or in the WAV file metadata, the timestamp, the all of the metadata that you need in order to make it useful, like what frequency you're listening to, the timestamp, the station call sign, all of that information. Because I think at the end of this Meteor Scatter event, I think that's going to be really useful information for trying to answer those questions that Mackenzie is posing here.
That's all worth looking into. But
Yeah.
let me make one other comment as long as this is up. Rich, K1HTV, who's been doing this since the 60s, mentioned to me to make sure people realize that if you're going to use WSJTX on 10 meters, you need to go in and add the frequency to your list of frequencies in WSJTX. And that's just done by going to where you set your frequencies. There's a list and you can right click on that and you can add any frequency and mode into that list. That way, when you go down to select the band, it'll show up. You see it. I'm showing 28,145, but it's not normally in the list. I added it.
Yeah.
So anybody that uses this will know how to do that.
Right.
Okay?
Does anyone else on this call have any knowledge of WSJT to the level where they know it would actually record scientific quality WAV files?
You could always ask Joe Taylor.
We certainly can. I just don't want to ask him, it could very well be in here because I know they think about these sorts of things. So I don't want to go asking if it's already there. But I think
I certainly have experience of doing that, Nathaniel, for Whisper, of course, FST4W, and JT4G, the JT4 series as well, where I have a separate Python or Bash script that accesses the directory where WSJTX puts its WAV file so that I can use separate processing on the same WAV file that WSJTX has handled.
So WSJTX it's actually saving WAV files to disk, Quinn?
Yeah, you can set that to either usually save all, each and every WAV file, or each WAV file where it has decoded a signal.
Yes.
And normally, well, with the JT4G stuff I've been doing, I set it to save all, and then my own processing works on that data. And if there's nothing interesting, I then delete the WAV file from WSJTX's directory. Otherwise, I save it and I can rename it to include the metadata that you referred to.
Okay. Is there so without you having, is there a way that WSJT can automatically save the WAV file metadata automatically, or do you have to go in and manually do something to it to make it useful?
It's not manual, but it would be coded in to a separate program. So it records date and time information as the WAV file, but the other information that you listed, it doesn't.
Yeah, I wonder if, I think, WSJTX is so widely used by so many people, and of course, an important part of this project, and I could see it being important for, future projects as well. I wonder if it makes sense to work with Joe Taylor and Steve Frank and the developers of this to try to improve the wave file recording so that it does include all the metadata. Because I think we'd really like to have it so that operators can just download a single program, this WSJTX, make their QSOs like they normally do, and not have to worry about, you know, saving wave files aside from telling the program, please save these wave files. And then after the event, they can just take those wave files and upload them directly to Zenodo or to wherever we tell them to put it. And we already know that it already has all the information in there that we need.
Yeah, that would be a cleaner solution, certainly.
Yeah, and I think yeah, if we could get them to include that in the program, then it would make it much more widely available to the community. Otherwise, I've seen this with like some of the solar eclipse festivals that we've done in the past where we ask for wave files. Yeah, you get people record wave files and you don't know when the thing started, when it stopped, or where it came from, or what frequency it was listening to, and then you can't really use the wave files. But if we have the program already knows all of that stuff. We just need to make sure that it actually saves it with the wave files in such a way that we can use it later.
For the second question, which we have on the Meteor, region of HF or region of the ionosphere which is getting affected by the meteors, since they absorb or around say 100 kilometer, HF absorption can play some role to detect the region through which the ionosphere is getting affected. But that will need some information of the signal strength. So do we have signal strength information in this experiment or any other experiment which we can set up? And that can give us relatively signal strength, and through absorption of the ionosphere, absorption of meteors in the ionosphere around 100 kilometer, that can indicate to what extent the region was affected.
I think the answer to that's probably yes and no.
Okay.
So if we save the wave files and we have all that information, you can get amplitude information out of that, which would basically be what it's part of what you want. But the other part of it is that all of the radios, especially when they're using them for communications, probably have automatic gain control circuits running, which are going to try to normalize all of the amplitudes that are received. So you're going to end up having all that information hidden. So if you can convince people to try to run the communications with AGC off and save the wave files, you might get what you're looking for.
Okay.
Nathaniel, in the WSJT.x instructions under audio, it does talk about saving wave files.
Okay.
So we just have to see if the functionality is what we're looking for.
Yeah, maybe Mackenzie, what you can do is on your poster for like the reporting and the data collection, you can say that one of the things that we need are the raw wave files. So in addition to everyone's logs, we actually want the wave files. And then one of the tasks of the committee for this project should be investigating whether the wave files as they're currently recorded by WSJT, are they sufficient for our purposes, or do we need the software modified in such a way to record additional information to make those wave files useful?
Okay, I'll definitely add that to the poster. Thank you.
Yeah, I think there's probably a couple useful things in terms of data that people could send to us. One thing, of course, are the raw wave files, and then the other thing are the actual decodes and the QSO logs and the decodes. Because the QSO logs and the decodes, they'll tell us when a successful communication actually occurred and who they were talking to, and then that will tell us where to look in the wave files to actually understand what was going on better.
Sure. Also, would you want me to send this to the Google groups, so that everyone who, if people did not join today, if they wanted to kind of look at it and give any feedback, would that
Yeah, I
be
think that's
possible?
absolutely. I think that's
Okay.
exactly the sort of thing we want. You know, the more eyes that are on this, the better, because, you know, this, I think, at least for me, I think Meteor Scatter is a more esoteric mode. I think there are certainly enthusiasts out there, but you know, I think the more people that we have looking at this, we might get someone to say, "Oh, you really should have thought of this or do that," and we really want that information.
Okay, I'll definitely send it off pretty soon here. I'll just have to make some more edits from today's call and then I'll send it off.
That's great.
Yeah, there were certainly a lot of enthusiastic responses the first time we mentioned this a few weeks ago, so I'm sure you'll get plenty more.
Do you know when in August this would be?
Let me double check. I think I have the dates up here.
It's all August 12th.
12th or
August
August
13th.
12th?
12, 13, 14, every year.
Okay, great. So not August 4, 5,
Yeah.
6, 7.
Right.
Good.
So the Perseids is a very broad stream. So you see Perseids a couple of weeks before and after.
Okay.
And there's also a secondary stream during that time, the Eta Aquarids. So you can get them coming from different directions.
And these happen every year, right?
Yes.
I think we should
Correct.
I think we should think about making this a multi-year campaign. You know, the NASA grant is for, you know, 3 years. And I think, I think we're going to do this the first time. And I think, you know, we'll get some good response, but I don't think we're going to get everything right. And it may take a couple of tries.
Yeah, August is probably a good lead time to put something together. But there are a lot of good meteor showers throughout the year, like the one in November, Leonids, I think. And then there's some others that are pretty intense.
And if we can come up with a really good procedure that's like, when there is a meteor shower, this is the way that you do a meteor scatter QSO party. You know, that could lead to a really interesting long-term data set.
You know, we know which
I've-
directions the meteors are coming from. I mean, that's how they're named. I wonder if there could be any correlations made with that knowledge and the path directions. And if there is, for example, let's say there's a meteor crossing your communications path at right angles. Okay, well, it's going to be there. It's not going to be there. But if you were looking right down its throat, if the path were aligned with the path of the meteor, you might see some Doppler.
I need to run, but this is a really good discussion.
Indeed.
So I'll let Gary, you know, you can decide if we keep it going or what. I'll leave the recording going. So I'm going to say 73 for now. But thank you, Mackenzie. This is fantastic. And thank you, everybody.
Thank you, Nathaniel.
Yeah. Gary, I've just got one item. Okay, just
Sure,
so
Ed.
that it doesn't fall off our table. Like this again, this is sort of my email exchanges with Joe K1YOW over the last couple of days. Is that I'm not into meteor scatter, but obviously I want to learn. So he sort of sent me a lot of instructional stuff. You know, and one of the points that he used is that for amateurs who are into it, is that the primary sort of centralizing source is Ping Jockey Central. Okay, if you take a look at the site. Okay, and one of the things now, again, just sort of a cursory examination, just sort of thinking about Mackenzie's outline, is that this, it's obviously a point where you look to schedule appointments, okay, or you look to discuss, sort of what you've seen and what you've learned. One of the things we might want to look at is, is this either a one-to-one, because it's a contest, okay? I mean, how does it work? How would that software work in a contest environment, as opposed to just a sort of pure, one-to-one QSO environment? So I don't know if that's clear or not, but nevertheless, I mean, we're going to need some sort of centralizing force, and it looks as though that might be a good place, to start for it. But again, in a contest environment, not necessarily in a scheduling environment. So.
But yeah, it's an interesting point is do you call it a contest and really make it a competition, or is Nathaniel calls, is it a campaign? You get the
Yeah.
Meteor Scatter folks excited about, hey, you
Yep.
guys know how to do this. We can use you and your stations to generate data over the next couple of years, and we'll see what comes of it. So.
Yep. So.
I got a couple things. First, Gary, is the agenda posted yet, or?
I'll put it in the chat right now, David.
Okay. And Nick, do you have? I didn't quite catch. Are you putting in a poster?
I'm not putting in a poster. I'm doing an oral presentation.
Oh, you're doing an actual talk.
Yes.
Is it going to be on the Eclipse?
It's going to be on the Eclipse data, how to handle the Eclipse data.
I see. I'm wondering if I'm not sure what we could contribute, but of course we were taking data as well for the Eclipse.
Yeah. And what you were looking for was the Dopplers.
Right.
And I think we discussed earlier that some of the medium wave 2024 data set was locked to frequency standards,
Right.
which would be good data for you people.
Yeah, we also do want to get the April 4th data somehow from you.
Yeah, well,
we can send you a hard drive.
Yeah, or if you want to save, border crossings, and one of Nathaniel's people are willing to do it, he has a copy as well.
Oh, okay.
I can just tell you what
Of the April data.
Yeah,
Okay.
what is available. Yeah.
Excellent. Yeah, if you could do that.
Yeah. Okay. Well, why don't you send me an email with
Okay.
what you're interested in, and we can figure it out.
Yep. Thank you.
All right. Mackenzie, do you think you got enough? I mean, you've got some information, some input to make some corrections, and I think going out to the Google group obviously is a great idea. And then perhaps we can continue next week and do a little bit more refinement. Would that be okay?
That sounds good to me.
Okay. All right. I also did a save on the chat too. There's a lot of good information in the chat. I use that feature from time to time, but if you open up the chat window and hit the 3 dots at the top, it is possible to save the chat if you've never tried that. So good. Okay. It is getting into time a little bit. If anything else everybody wants to finish up, otherwise we'll call it a wrap for the week. All right, wonderful. Well, thanks everyone for your input, for your patience, and for participation today. So we'll say 73, and hope we see you all next Thursday, if not sooner.
Before everybody leaves, can I make a shameless commercial plug?
Sure, Eric, go ahead.
Okay, well, I gave the address for my website. These are lovely wind radio SDRs. I got a half a dozen of them, and they are from another science project they were doing up here. And you can see this on my site if anybody needs them. They're high end. They aren't cheap. Also have these lovely ELF coils. These are the BZ6s or BF6s. I have 3 of them for 3-axis magnetometry. So if anybody's looking for this, I'd like to do some experiments up here, but if anybody needs these, they're sitting around waiting for somebody to adopt them. So, and I got tons more of this kind of stuff here. Lots of microwave equipment. I'm Radio Shack North. I could show you some photos here, but I got literally millions of discrete components here. So if anybody's looking to put stuff together, if you can't find it at Radio Shack, you can find it here, guaranteed.
That's interesting, Eric. Thank you very much.
All right, thank you.
All right, good enough. And I just see I'm saving the chat. I see a comment from Jamal regarding the abstract, and I can definitely take care of that. And I'll get back to you on your question. All right, thanks everyone. And Mackenzie, you want to stick around for a minute?
Yes.
Thank you, everyone. I'm still trying to figure out Meteor Scatter stuff, but I'll get it worked.
You might have a couple of years, Gary, so that's all right.
Well, actually, while you guys been talking, I've been playing with WFJT and meteor scour or chatter settings and all that. So it's not too hard to set up. So from what I've been reading, so I'm looking forward to definitely getting involved in it. Looks fun. So thank you, Mackenzie, for coming up with the idea. Thank you, Gary, for running this thing, and I'll see you guys later.
All right,
Bye.
Gary, take care.
Have a good weekend.
Bye.
Okay.
I think
I
that
just
was
wanted
pretty. Yeah, go ahead.
to, I just wanted to double check on that one question. Let me see if I can go back to it.
Thank you, Gary. Thank you, Mackenzie. Just need
Thank
to
you
go.
very much. Have a good
Thank you.
weekend.
Yeah, bye.
This question right here. Do you think I should just take this one out,
The number
in
3.
your opinion? Yes. Do you think I
Actually,
should
no.
just-
When I first looked at that, I was thinking, meteor size. I'm thinking, how big is it in meters or kilograms or all that sort of stuff. But Mary Lou made the point that, sometimes the size of the thing may be determined by the brightness. And if there's a meteor watching network, for lack of a better term, they can correlate saying, at 1331 UTC and such a date, we saw these brightnesses of meteors. That may be an indication of size. So, and then we can compare that to our radio data to see how many QSOs were successful at that same time. And you may really have something here.
Okay.
Something
That makes
something you
sense.
guys want to look at?
Sure, Wayne.
Hi, I just wanted to interject this quickly. I was going to keep silent, but NASA has a meteor shower portal. There's all sky camera networks they have that take images all night and records the meteors, the direction they came from. I'm not that familiar with it. I just found it, but it's NASA Meteor Shower Portal. It's CAMS, CAMS.SETI.org. I could put that in the chat probably.
Oh, yes, please do.
But and they record that, so you could use this for correlation.
Oh,
Maybe.
thank you for letting me know.
Yep.
But yeah, I just wanted to double check what you thought, Gary. That's pretty
Yeah,
much it
no,
for me.
I like I said, my first inclination was, how the heck are you going to do that? But then listen to some of the others. That's the beauty of having a big group. People, you got a lot of
Right.
knowledge to pull from. So I would
And
leave it in there
I'll
for
make sure
now,
to
and
send it off.
especially the folks in the Google group will see it. And also, if it stays on the poster, we'll see what kind of comments come back from the folks viewing it in New Jersey. So.
Yeah. But yep, that's pretty much it for me
Okay.
for today. And I'll be in touch. I'll make sure to be in touch about the poster and everything.
All right, very good. Well, so far so good. Nathaniel is sure impressed. That means a lot. So.
Yep, it'll
All
be
right,
impressive if we can pull it off.
Oh, it's going to take some work to get there, but most things worthwhile to do, right? You know that, obviously. So.
Absolutely, right.
Yep. All right. Hey, when do you get the feedback from your MCAS back?
It takes a couple weeks. It's gonna take a couple more weeks. Usually it takes a whole month for us to get our scores back, so I'm still waiting.
It's got to be sitting on pins and needles waiting for that to come back.
Oh yeah, absolutely.
All right. We'll be in touch. Good talking to you.
Yep. Have a great
Have a good
weekend,
one, Wayne.
everyone.
Take care. 73.
73s.